Hello, everyone, and welcome to today's webinar. My name is Celeste Strupp, and I will be your moderator. This webinar is brought to you by the Critical Materials Innovation Hub. Today's topic is diversifying low-purity gallium production beyond China. Our two presenters, Dr. Tien and Dr. Srikar, are from Idaho National Laboratory. Before I introduce our presenters, I would like to review a few webinar logistics. This webinar is hosted by Colorado School of Mines. It is a public webinar and it will be recorded. That recording will be available in about a week's time, both at aimslab.gov/CMI and at our YouTube on the Critical Materials Innovation Hub channel. If you have suggestions for a future webinar, please include it in the exit survey that will be sent to you via email at the end of our webinar today. If you have questions for our two presenters, please feel free to ask those at any time and type them into the chat box. They will be answering those questions at the end of today's presentation, but it's always best to ask them when you have them. With that, I would like to introduce our two presenters. First, Tien is a staff scientist at Idaho National Laboratory, who previously was an oil and gas refining industry project engineer, where she developed processes, designed equipment, conducted feasibility studies, and prepared basic design engineering packages. Currently, they're working on some critical material work at Idaho National Laboratory, looking at rare earth elements and their life cycle assessments for emerging technologies. Next, we have Srikar. Srikar is a postdoctoral researcher within the Decision Sciences Department at Idaho National Laboratory. His research focuses on using generative AI, modeling and simulation, optimization, and data sciences to address various challenges in the critical material and supply chain sector. And with that, I will pass it off to our two presenters to share their presentation, and then we'll have some time for questions at the end.
Yeah, thanks, Celeste, for the introduction. Hello, everyone. My name is Tien. Today, me and Srikar will represent our team at INL to present our work, how to diversify gallium production beyond China. So in this talk, we will have four sections. A little bit introduction about gallium, so a little bit about our approach. We will show the results of this approach, how it looks like, and at the end, we'll have some conclusion. Of course, we'll have Q&A and section at the end as well. So yeah, let's jump start with the gallium. So you already know that gallium is critical materials, and its major application is in semiconductor. So any radio frequencies applications that you see in smartphones, satellite, defense system, it have gallium in there. They also in the integrated circuits and also in the LED. And the second major application for gallium is magnet. So it in the high temperature application, you can see in wind turbine, in motor, in robotics. And last but not least, they also available in photovoltaics, in solar cells, in medical use, and also in the catalyst as well. The recent years, we can see that the huge jump in the demand for gallium. Also one part of that is because of the growth of the AI and data center. And with that is the semiconductor application. One of the things that we have to note is for the semiconductor application, the gallium requires at least 6N for this application. When I say 6N, it means 99.9999, so 69%. And this is the problem for US right now because we only have one facility refine 4N to 6N only, and we don't have any domestic supply for 4N at all. In the world, China controls over 90% of those supply. So to make things a little bit more complicated, gallium is not the primary products. It is the byproduct of alumina and zinc production. So first, let's take a look on the geographic coverage on by continent right now. So for alumina-refinery, right now we have more than 20 countries say that they have the refinery and it's across 6 continents. Similar number for zinc-smelter. However, for gallium, we only have 8 countries. as you can see here in the map in the gray color here. And they just located in the Europe and East Asia only. To be fair, although it is a country, but 90% of that is controlled by China. So we ask the question, what if we leverage the existing facility for alumina and zinc, and we integrate gallium extraction into those, how it look like? So that's the reason why we have come up with this work, that we ask ourselves if we want to diversify gallium productions and integrate gallium extraction into those existing refinery and smelters, what is the global cost variation? Which country will have more supply risk than the others, and what is the regional cost driver for those? So in our team, we have around 6 expertise that we can leverage to answer those questions. Due to the time of the presentation, I will present 4 of those. It will be the process flow diagram, devise and develop, techno-economic analysis, cost flow analysis, and the supply chain analysis to be able to help us to answer those questions. And to answer the final overall question is that which country had the cost effective and be able to produce gallium in the sustainable way. So with that, let's summarize on the approach that we have. The first is which country and which asset it does. So for right now, with the purpose is to diversify the gallium productions. For each country, we select the largest alumina refineries or zinc smelter. Beyond that, we select the countries and the assets name. And then we use the reference facility because a lot of them in those countries, we don't have enough information to derive from what is the gallium capacity for those countries. So then we use the reference facility in US. So the one that we use in the alumina refinery in Louisiana and zinc smelter in Tennessee to add the reference facility to derive the with its capacity, whether this will be the order of the gallium capacity or the germanium capacity. With that, we're able to have the new map here that you could be able to see which the country with feasible for alumina pathway in the green color, which the country that has the zinc pathway possible, it will be in the orange color. And now the map you can say that is more distributed for the gallium production. So then we want to answer what did the cost look like for different countries, right? So the approach that we use in our work is bottom-up approach. So basically that we need to have the process flow diagram and the mass balance for that. So for gallium production, actually they have 2 main pathways. They have this pathway in the commercial scale. So at the commercial scales, actually more than 90% of gallium productions follow alumina blends pathway from leaching from bare liquor, and then they have the gallium metal at the end. Around 4 to 10% of gallium production follow zinc blends pathway. Currently that they follow that based on the zinc leaching residues, and this one is a little bit different with bare liquors. Why bare liquor? They have only one product, gallium. For zinc smelter, they have co-production. It means that they will be able to get gallium out at the final products and also germanium. So it's a huge difference between these 2 pathways. So to derive the process flow diagram at the commercial scale, we use a Chinese refinery, gallium productions in China with the capacity of 80 tons per year for our derived process flow and mass balance here. For the zinc pathway, we use the report from company in China as well for the process flow diagram, and based on the pattern with the example of around 10 tons at the unit for the feedstock to derive the mass balance. With Thus, we'll be able to get out the equipment list of each pathway. This one, I just saw the example for the aluminum pathway only. We have the same list for zinc pathway. And after be able to get that, we be able to calculate the capital cost, CAPEX, or the operation cost, OPEX, and we also do the cash flow analysis. One of the things that we want to highlight in our work is that we do this one at the asset level. So basically, it means that the equipment cost, the material cost, the utility cost, also at the country level. So it's different for each country. And also for the cash flow, we also apply different finance structure for those countries. We have to take into account the tax rate, the cost of equity, the cost of debt, to be able to calculate the NPV and IRR at the end. So that is the main difference in our work. So with that, we go be able to calculate the cost for each country. So in the first, in the left figure, you can see here that is the 6 country in alumina pathway. And in the y-axis, it will be their cost. The cost here will break down by each contribution for the CAPEX and also major component of the OPEX as well. With the, after doing that, we benchmark our cost with the a lot of dashed line that you're showing here. The rest dashed line is the current SOP China price. And also we benchmark those with the historical price. The line here showing the minimum in the last 10 years, average in the last 10 years, and maximum in the last 10 years of the FOB price. And as you can see here, for the aluminum pathway, the cost is kind of vary between different countries. Among countries that the India have the lowest cost, and it's lower than the average FOB price. A little bit higher, it will be Guinea and Brazil have a little bit higher than the cost, but they also still lower than the current FOB price from China. Whereas the US, Greece and Australia have much higher cost. We do the same analysis for the zinc pathway. And one of the things that we are noted at the first sight is that for 6 countries that we have for zinc pathway from Canada, Peru, South Korea, Namibia, Spain, and Australia, that's the cost in the range of 420 to 520 each. And then you can see here, compared to the cost from aluminum pathway, you can say that the cost for zinc pathway is much higher. This is the main purpose, the one of the reasons contribute to this one is you can say that if from the yellow color here, it actually the chemical cost. The chemical cost for zinc pathways need to account for attract both gallium and germanium. And again, this is the cost allocation by mass only. So that's why right now, because they need to attract 2 metal instead of 1, we have much higher cost allocation in here. Nevertheless, with this one, we will to see that with the zinc pathway, South Korea is the one that had the lowest cost, and it kind of comparable with the current FOB price. With that information, we're able to derive the cost curve for non-Chinese gallium supply, foreign gallium supply. So this in the left figure here, you'll be able to see that, India have the lowest cost, but Brazil have a little bit higher, but their capacity is much larger. US and Canada is kind of in the same range here, and the last is the highest cost is belong to Australia. So the huge sum that we see from Brazil to Greece, where we are brought to close to the FOB price. As I said, in this work, we also be able to have the zinc pathway as well. So based on that, we also have the germanium. So that the reason based on this work, we'll be able to have the cost curve for non-Chinese foreign germanium oxide as well. This is again that based on the mass allocation that you can see that the South Korea have the lowest cost, also the largest capacity when across 6 countries that we analyze right now. But as I said, all these results I present up to now is based on the mass allocation. The reason we want to do that is because we want to show you if we do the mass allocation, how it look like. However, for the investor, actually, they care about the economic drivers. So that is where the allocation is much more sense if we do the economic allocation. So basically, it's based on the mass and the values of the final products. So for the alumina pathway, it doesn't change the story much. Actually, it doesn't change at all because for aluminum pathway, we only have gallium, only products. Whatever you allocate mass or economics, it will remain the same. However, for zinc pathway, this is changed. Now we have gallium and germanium at the co-products. So then if we all know that germanium price is much higher compared to the gallium price. So if we do the allocation, the cost production cost will change. So actually that we can see it here at the in the lab is gallium production cost when we do the economic allocation, that all the cost is reduced right now. That before, you remember the all of them is close to the FOB current FOB price, but now they reduce to between the minimum and average FOB price. Same for germanium. Actually, the germanium right now, because the value at the end is higher, so then the cost allocated to germanium should be higher. So then right now it's approach close to the minimum FOB price right now. However, the trend is remain the same for the between the mass and the economic allocation. We still be able to see that with the zinc pathway, South Korea showing that it will have the really cost-effective country. So with that, I should explain to you how gallium and germanium for the economic allocation can change the cost if we under the perspective of the investor. So to make this even more, we also do the supply chain analysis here. That, as I said before, even though gallium, germanium, they can have different values. However, they both either byproducts. It means that they depends in the primary products of the refinery or smelter, which is aluminum, or zinc. So in this one, I'll be able to see the results for zinc pathway across 6 countries. So you can see here for for alumina refinery, that if we integrate gallium facility in that, gallium's revenue percentage at the end is lower than around 6 to 7% only. And the main contribution is still come from alumina. So again, it is showing us that gallium production is not primary economic driver. So we'll be able to do more to take a look in, okay, then what is the profits that come from? So across all the country, we have in the green color here is the country that have profits with the current price. And you can see that the most country that have the high profit is Australia's, followed by India's. And then we said that, okay, they have profit, but how it's sensitive to that profit. So that way we calculate the margin of the safety. So this is the one that we calculate how much the price of primary products, so basically in this case, alumina, be able to reduce, that will cross out all the profit. And then if the gallium aluminum plant not work doesn't work operate anymore, then it will make the gallium supply go down with that. So that is the reason why we see here for Brazil, although they have a comparable low cost, but they really sensitive to aluminum price. Only change around 0.4 cent per kilogram of alumina is enough to take the gallium off the market from this refinery off the market. And also see a little bit better compared with other country, but it's in the range of around 40 cents to 50 cents per kilogram only. So for alumina pathway, they can be profit, but it's really sensitive to alumina price. We do the same analysis for the zinc pathway, and we see the same thing, that the gallium revenue at the end is really small. It's even smaller than the alumina. That in this one, it's just around 2 to 3% only. Lucky that for this pathway, I would say lucky because they have the high price for germanium, so then they be able to mark up with the loss from gallium extraction in process. That right now germanium oxide is actually around 50% of the revenues. So same, we do the margin of safety, and because they have the germanium in this case at this buffer zone, right now the margins of the safety, you can see it close to 3 kilogram per US dollar per kilogram. So often those the gallium's production from this one may not seem profit. You can see here it all negative number here, but it's less affected by zinc price. So this is two really different story from aluminum pathway and zinc pathway that we can see here. Next is that, okay, we know the cost, we know the dependent, how it will be sustained, whether it's sustainable in the future. So that if we use one of the factor here, that either political regulatories and social factors. This one is derived from the World Bank and also the US University Index for those countries, and we average those index. So in the figure here, you can see in the x-axis, it will be the production cost, and in the y-axis, it will be the average index. And we want to have something in the left corner here, that we have the low production cost, but high index. So that is mean that it have cost effects, and it may have the sustainability. However, for the country that or this country that we have for aluminum pathway right now, the lower cost belong to India and Guinea, but their index is kind of low. So the one that have the balance between the cost and the index actually is Brazil. They have a little bit higher than compared to the cost, but they have the average index is a little bit better compared to India's and Guinea's. For aluminum, for the zinc pathway, same story. We want to have something in the left up corner here. And lucky, I don't know, lucky or not, but for this one, we'll be able to allocate the one country that seem to have those factors, that is South Korea. So showing that South Korea from our study, showing that they have the low cost and they have a fair index compared to other countries as well. So it is something that we want to say that we need to consider for the cost, but we also need to consider for another supplier risk assessment as well. So the last question, with all of that done, whether we be able to diversify the gallium production or not. So to do that, we use the index, the SSI index, that for the producer diversity. So this one is historically based on the index. This index we separate our market into 3 areas: competitive market, concentrate, moderate concentrate, and highly concentrate. And the number is a little bit changed. Before that's why I call historical and now. Before 2023, they use a cut point around 1,500 and 2,500. After recently, the Department of Justice changed their cut point to 1,000 and 1,800. again, the story is that with the existing capacity right now, the SSR index that we have is close to 8,000. So it's really highly concentrated. It will fall in these areas. However, if we do this work, that we be able to extend the gallium production to another, 11 non-Chinese country, then the HHIs will reduce to around 2,000. So it is a significant reduce in the producer intake, is showing that we be able to have the productions of the gallium is close to the moderate concentrate, or even close to in the future it may have to close to the competitive market. So with that, I would like to introduce my colleague Srikar to help you to understand how we be able to consider all of that into the different country for the finance structure.
Thank you, Tien. So what Tien presented up till now was the techno-economic analysis of producing gallium in these different countries. Now, once you produce it, you got to sell the gallium as well. So we did extend our techno-economic analysis into a full cash flow analysis. And to do that, we had to understand the economic competitiveness across countries in various continents. So to do this, we used the CapEx, the OpEx, as well as the production flows from the techno-economic analysis presented earlier into estimating the minimum selling price for each of these continents and countries. So we took different payback periods. Payback period is essentially the time before your investment, your revenue meets your investment. So we took it across different payback periods. And as you can see here, all the minimum selling price in these bars, they decrease with increasing payback periods, meaning that longer project times give you, you can sell your product at lower prices to get back your investment. So we tried comparing these MSPs with current and historical FOB prices that we had obtained. And as you can see there, it is also very region dependent for both pathways and follows a similar line of results as what Tien had presented earlier, with India, Brazil, and Guinea showing the lowest costs in terms of their MSPs in the aluminum pathway, and South Korea showing the lowest price in terms of the zinc pathway. And while calculating the MSPs in the zinc pathway, we accounted for the GeO2 price because that gives you an additional revenue on top of the gallium as well, which is not the case in the aluminum pathway. Next slide here. So similar to the cash curves that you saw previously, what we also did was extend that minimum selling price into cash curves, but also represented in the form of different payback periods as well. So depending on the kind of financial investment and financial attractiveness that investors are looking for, different countries present different economics, and therefore, depending on the amount of metric tons, the best countries are being shown here in these cash curves. So as you can see there, India would be great to start off with in the alumina pathway, and depending on your payback period, either Guinea or Brazil would be the next best, and so on and so forth, where USA and Australia seem to have the highest prices. And in the zinc pathway, it's something similar with Korea, followed by Spain, and then Australia and the other countries. So overall, we see that financial attractiveness, even though longer payback periods may not seem attractive at the start, they do give you a more significant and sustainable non-Chinese supply, and also lower back your minimum selling price as well. So even though it may not seem economically competitive, longer payback periods are seemingly positive as per the cash flow analysis that we performed. So we calculated the break-even price for the different continents. So the question then translated to what would be the overall long-term investment? What would I get by investing in this project of gallium production in the different continents. So over a lifetime of 30 years, we calculated the net present value, which accounts for future cash flows, the revenue, the amount of investment that you've taken. And the net present value, it calculates the profitability of that investment over the lifetime. So in the alumina pathway, as you saw, India and Brazil had one of the lower costs. So they're seemingly more economically better than the other countries. So their NPVs are positive, while over in USA, Australia, your NPVs are negative. While it follows a different story in the zinc pathway, where you can see that all of those NPVs are highly positive. That's mainly due to the GEO2 co-product revenue that drives those high prices. So as Tien mentioned, the zinc pathway seems to be highly influenced by the co-product rather than gallium than itself. While in the alumina pathway, it's very dependent on the cost of alumina as well as minimal cost of gallium that was found. So in terms of long-term investment, the zinc pathway seems more economically profitable because of the GEO2 co-product revenue. And as I said, it's very region dependent, so it depends on which country as well you're investing in. So having shown you the cost of production of gallium, as well as showing you what is the long-term cash flow analysis, the question is, which cost drivers kind of affect the overall production of gallium in the different countries. So we took various factors that were calculated in our OPEX, which include gallium concentration, chemical costs, utilities, and we performed an initial sensitivity analysis, but we found greater value in something called an elasticity analysis, which looks at the percentage change in output to the percentage change in the input. So it's more, think of it as a more dimensionless form of sensitivity analysis. So on the plot here, we're showing you a log sensitive elasticity analysis for the alumina pathway, with positive numbers showing you factors that increase the cost of gallium production, while the negative elasticity costs reduce the overall system or gallium production costs. So you can kind of see here in this figure itself that factors like labor cost, NaOH, electricity costs significantly increase the price of gallium production, while higher gallium concentration, as you can see in the red bars there, they consistently lower your system costs. So these are also very region dependent. And as you can see there, India, Brazil, and Guinea are significantly affected, which follows the same pattern as what we've shown you so far in this presentation. And on the next slide, we show you the zinc pathway. And a similar elasticity analysis was done for this as well. Unlike the alumina pathway, gallium and NaOH costs show a more significant impact here because, as Tien mentioned, more chemicals are being used in the zinc pathway, and with NaOH being involved in the leaching, impurity removal, and other steps as well. And we can see that from this two figures that the gallium concentration is a key cost reducer in both production costs and in both pathways, but the level of effect seems to differ from country to country, and the factors responsible for that level of change also differs across pathways, with the gallium concentration and NaOH being more significant in the zinc pathway compared to the alumina pathway, but the alumina pathway is more affected by regional labor and electricity costs. So having said that, we just wanted to kind of conclude by saying, or leaving you with a few key takeaways from our presentation today. This study that we conducted assessed gallium production across 11 non-Chinese countries and 2 processing pathways. We did TEA analysis, cash flow analysis, economic competitiveness, supply chain risks, policy, regulatory, and social factors as well. As overall, you can see that the alumina pathway results in lower gallium production costs than the zinc pathway, with high sensitivity to alumina prices, which is not the case in the zinc. In the zinc, the GeO2 seems to increase your prices significantly, or lead to a lot of the price in that as compared to gallium. As we showed, some of the countries seem economically competitive, but not from a social and policy side. And as you can see there in that table, India and Guinea, even though they have the lowest cost, they have high environmental risks. So overall, we were looking at expanding the production in these non-Chinese countries to improve market diversity and reduce any supply chain vulnerabilities. And with that, I'd like to acknowledge funding by our various sponsors from the DOE, from Critical Minerals and Energy Innovation, the AMTO office. And we'd also like to thank Dr. Fu Zhao, Dr. Menshi, and Dr. Yuan Li for their help with data compilation. And yeah, with that, we'd like to open the floor for any possible questions. Thank you.
Awesome job. Thank you so much for your presentation. We're very informative. Are those, please ask questions in the chat box. I can get us started with a question. So you guys identified, I think it was 11 non-Chinese countries where gallium production could potentially be expanded. From a deployment perspective, I guess, what is maybe one of the biggest barriers for actually developing these alternative supply chains? Is it, you mentioned like economics, is it the availability of the gallium, environmental regulation? Does it depend per country, kind of what the highest risk factor or barrier to developing these are?
Yeah, so thanks, Celeste, for the question. So I can take this one. So I think this is really a great question for the decision scientists. So I would say that it actually is a sum of all those factors. So basically that in some countries we have the lower cost, but if we look for something in the future more sustainable, we want to have it, have we don't want to have it supply one day and the next day it will stop, right? So that is something that for the long-term investments, I think that all those factors need to be contribute to the decision of the investor. So for those I think right now in some country, if they are the reason why we want to the country that already have the existing facilities, because we want to lower the first barrier, that whether they have the manpower, we have the size, they have the feedstock or not. So they have those ready already. And also the reason why we choose to go with the commercial technology right now is because we want to if apply it in the faster ways to do, so how it will look like. However, saying that this is something that we haven't been able to present, but we have to take into account for those pathways, they all use the resins at the core technology. And right now, although we try to expand to non-Chinese country, for the resins right now, it's still get a really contribution from China. That is a Chinese supply is the highest one right now. So if you want to really use this technology, they also need to consider produce those resins and those chemicals outside of China as well. It is something that for deep dive into the supply risk, we will be able to do more. But due to the time of the presentation, we just say that it is some of the supply that we have. So this is more than one question, or I think more than one factor that we need to consider. So this is something that we want to provide a big picture for investor. Those factors make sense and how it contribute to your decision. Yes, so I think that's the short answer is that we need to consider all of that.
Thank you. Yeah, I'm sure lots of factors contribute. Very diverse problem. I see we have a couple of questions in the chat. I'll let you guys read those and take those on.
Yeah, so I think the first question is that the audience wondering if we evaluate the viability of zinc pathway for gallium production in US, and given that the production pathway are sensitive with the gallium concentration, some zinc deposits could be more interest than aluminum source. So yeah, thank you for the question. Yes, I can answer this one. So for the first question is that whether we consider the zinc pathway for gallium production in US. So the answer is that for this work is not, because we select US for other way that we do is we select the high gauge, the large gauge capacity for the zinc and aluminum zinc smelter and alumina refinery. So that's the reason why for US we have the capacity for zinc pathway is higher. I acknowledge the pathway that it doesn't say that. I mean, based on our work, it doesn't mean that US cannot pursue the zinc pathway. It just say that we have more likely have high capacity over there if we consider the average concentration. So this is also one of the limitations that I want to admit, that in this work, we use the average gallium concentrations. I know that that's the reason why later when Srikar have his sensitivity analysis, you can say that gallium concentration is really a cost reducer. So in case that if there are a mine or the resource that have higher gallium concentrations, and then I think it makes sense to consider it for zinc pathway as well. So yeah, so that right now it's just because of the information that we got. We have some information for US, but not for other continent. So that's why if we choose to include all that, it's just out of scope of the work. But we encourage that everyone to take a look in the sensitivity analysis to see that if your assets have higher than the baseline of the gallium concentration that we have right now for across country, and you have higher than that, that is the main factor for you to reduce the cost, and it will make your asset, if you follow that pathway, it may be possible and make the profit out of that.
There's another question in the chat box. So did you take into account the various timelines alumina and zinc production routes will take? And I can probably take that one. We did. We evaluated a lot of different pathways that these feedstock could take, but we found these two to be the most commercially viable. And then we dived deep into the TEA analysis. But once we finished the TEA analysis, we also wanted to take into account what would it take for the revenue, or how long would it take for the revenue to meet our initial investment. So we calculated it over different payback periods just to find that out. So we did account for it, but maybe in this presentation we showed the two commercially viable ones, but we did evaluate the other feedstock that could be possible. Tien, there's another one, probably a
so
question
the next question is, what were the criteria or the threshold that you use to select zinc pathway over aluminum pathway in a country? For example, I would think that you could perhaps use a mix of both, similar to how you have considered in Australia. So for this one, yes, thank you for the question. The original purpose of this one is we want to diversify it as much as possible. So it means that if a country, so right now we use a threshold that we will select one country based on whether it will have the highest capacity for aluminum or zinc only. So basically that we have a list of a lot of hundreds of gallium, a list of alumina refinery in the world, and based on each continent, we will select one largest asset for those continent only. So this is the reason why for US, yes, we can have both. However, for Canada, they have the higher capacity for zinc smelter in Canada. That's the reason why when we do for North America, only US we be able to select for aluminum pathway, and we select Canada for zinc pathway. Yes, so I hope that I answered that question. If you have more questions, want to ask, please email me or connect through our LinkedIn. We're happy to test more. Yes, so the next question is for the slide deck. Yes, please, if you want to have the slide deck, please email us. We can be able to we'll be able to distribute it. The next question is, could you please evaluate a little on the range of the gallium percentage in zinc-based feedstock that was made gallium recovery from U.S. economy variable, considering region consumptions and associated processing costs? Yes, so right now for the I see that a lot of questions are for zinc pathway, and yeah, the paper actually for this one we have all this data in the paper that we will publish soon. So yeah, it's in the SI. Anyway, for this one web question, I will say that yes, we right now the gallium concentration that we select for our base case is 200 ppm for all the country. And when we do the sanity analysis, the gallium concentration is vary from 100 to 300. Same for if you care about zinc pathway, I would say that this is the range that we have. And actually to make the gallium zinc pathway more profitable in US, actually we should also consider see about the germanium concentration as well. Because again, for zinc pathway, germanium is more attractive and have more revenue compared to gallium. So if you can consider gallium and germanium as a separate refineries, the germanium should be the primary and gallium is the byproducts. In this case, because they are connected to zinc, so we can call it the co-products of those, but the germanium have much more value on that. So for germanium, for US right now, actually because we don't consider for US for zinc pathway. However, I can tell you that the baseline that we use for zinc pathway right now, it's a 2000, I'm sorry. Yes, 2000 ppm, around 2000 ppm for germanium in zinc leaching residue only. And this number for US is much higher. So if US want to consider zinc pathway, I would consider that they may consider for both gallium and germanium in this one.
And just to add to Tien's point, the sensitivity analysis that we considered in our study was about 50% from the baseline, as Tien mentioned. So it was 50% above and below. So that gave us a wide range to kind of make our assumptions on the results and evaluate them. So yeah, just wanted to add that quick point. There was another question asking, you did not consider Canadian alumina production. No, not in the study we did.
So
Tien,
for that, actually, we did we'll say that it's two steps. So the
yeah,
first one is that we consider all the aluminum around the world and for each continent. And then yes, Canadian aluminum production were in the lead, but when we select the country to move forward, we just select the highest capacity. So
exactly.
that's why the Canadian is not met in the shortlist.
Then there's another question there. Since you consider production pathway based on highest capacity, does having highest capacity really matter in terms of satisfying gallium demand? My understanding, US has enough resources, both alumina and zinc resources, to satisfy gallium demand.
Yeah, so yes, again, that for this question, I think that we are not disagree with your ideas that and the comment that we agree with that you have the resource. However, for this one, we need to have the fair comparisons and the gallium demand, which is some of the information is that um, confidential, so we cannot be able to disclose. So that's the reason why in our work we use the average gallium demand for across the country. So that is one of the limitation in our work, that since we cannot disclose the confidential information, we use the average one. So that's why for each country, for the assets that not in the list that we have right now, I was encouraged to see the sanity analysis to see how that when it adjust to the concentration that have in US, how it look like. And that's also the saying that when we do the highest capacity, right now we assume that we have the same concentration for gallium and germanium in the feedstock that we have, which is actually is not it's just the best approach that we have right now because we cannot disclose those information. However, we can say that right now, based on the refineries, for example, it's really well known in the world that all different gallium ores have different gallium concentration, and it really vary across the world. But depend on how the refinery and the smelter operate. I mean, by the temperature, how much they circulate the liquid, or how much they leaching out, or how much acid, or how much temperature that they get. They are starting from lower grade of ore for gallium. It doesn't mean that they will end up at lower concentration for gallium in the those feedstock. That's the reason why, since we cannot disclose that temperature, pressure, and circulation, we use the average. But this is something that at beginning, the reason why we want to share with you why we choose the highest capacity in this one to move forward.
But just to add to Tien's point, even though the limitation that we acknowledge is that the gallium concentration was assumed to be similar or the same across all the continents and countries, we as a team were able to collect information on country-specific chemical costs, labor costs, utility costs, and cash flow requirement costs to perform the analysis on an asset level and on a country-by-country basis. So and the sensitivity analysis and elasticity analysis also helped us account for any uncertainties with those values to better reflect and better understand what are the key cost drivers as well. So just wanted to mention that that even though we had that certain limitation, this is on a country by country basis to better understand the cost of producing gallium in the different countries.
Yeah, thanks, Srikar. I think we have the last question here. What are your thoughts on this recovering gallium from end-of-life hardware components? Do you think the secondary recovery pathway could be made cost-effective and eventually better than the primary pathway you investigate? Okay, so yeah, really, this is really great question, and thank you so much for the question. We actually have the work right now that also funded by Atom and CMI to do the analysis to see what is how much the person cost if we recycle the gallium from e-waste. I mean the end of life device. And first of all, that for gallium we mostly see it in the integrated circuit board, and also we see it in lining and other component as well. The one that we see is for sure that the production cost may higher. The reason why I say that is because right now it's not because of the separation, leaching, or the other things. It is our concern right now is the collection cost, and the collection cost is right now first is the collection rate in the world and also in US and different countries is really low right now. And the second one is after we collect, we need to disassemble it, and more of them is right now using by hand. So meaning that it will be a huge labor cost there to set out the different components, sort it, and then ship it to the country. So right now, I will say that the challenging that we have, I think the technology, I see a lot of R&D work in the different technology to leaching out and recovery the materials, gallium from the end of life device. How I think really positive on the move forward of the R&D impacts. However, our concern right now is the collection. We got that feedstock. Whether we be able to secure enough the feedstock to make it, sustainable, or we can make it to urban mining that worth the investment on us. So this is the main concern that we have when we come to that one. Yeah.
Great job answering questions, and thank you to the audience members for asking those questions. They add a lot of value to our presentations. If you would like these slides, as Tien mentioned, please do email them, email one of them, and they can share those slides with you. Tien, if you would go to our last slide, we're going to wrap up our presentation today. So this webinar will be available, and the recording of this webinar will be available in about a week's time at our YouTube channel, which was linked in the chat, but will likely be linked again for those of you who aren't familiar with it. You can also find the recordings at aimslab.gov/CMI. You can see future webinars and upcoming webinars for September and October will be listed in our Critical Times newsletter, as well as at aimslab.gov/CMI and on CMI's socials such as LinkedIn. So please follow us there for updates on future webinars. You will be receiving a short feedback survey at the end of today's webinar, maybe a little later in this afternoon. And with that, you can send us ideas for future webinar topics and give us your feedback there. You're also welcome to email us at cmi@mines.edu with any suggestions. And with that, I will end us for today. Thank you again to our presenters. Fantastic work. Really appreciate your time and effort that you went into sharing this information with us. For our audience, I hope all of you have a wonderful rest of your day. Thank you.